So now we're going to talk about measures of dispersion. Measures of dispersion are yet another way of describing a set of scores for one variable. So like we discussed previously, measures of central tendency, we discussed the mean, the median, and the mode as the sort of average score around a distribution of scores. The measures of dispersion are really describing the degree of which those scores are dispersed around that mean. It's also described as sort of the variability. It's sort of the noise around that mean. For example, you might see a mean of 4 cups of coffee per person from your data, but that's not. There's a lot of noise around that. That it could be as many as 5, or it could be as little as 3 cups of coffee for a given population. So there are 4 different types of measures of dispersion that we'll be discussing, and in this particular slide session we'll be talking about specifically the range and mean deviation. But there are also the variance and standard deviation, which will be discussed in further videos. And this all comes with one big warning, and that is that much like with the means and medians, there are actually 2 approaches for calculating dispersion. Which is, again, the variability around the mean. It's one version for the raw scores and one version for the frequency data. And we will make it very clear to you what we want. Most often, you will be actually calculating most of your stats for raw scores, but it is possible that you might need it for frequency data as well. So the first measure of dispersion is the range. The range is by far the easiest one to do. It's very straightforward, and there's no actual calculation per se. In fact, it's probably the least useful in terms of measures of dispersion. But it's essentially, the range is looking at the highest score and the lowest score and just giving me the range. So for example, we calculated an average of 8 cups of coffee per person, per student, within our survey of 48 students previously. The reported number of cups ranged from 0 cups for a certain number of people and a max number of 12 cups. So the range is just that, 0 to 12. You could write 0-12 or 0 to 12, it doesn't matter. It's not really that useful in the sense that it actually is very much heavily influenced by the extreme values without regard to any of the other numbers in the data set. One thing I wanted to point out is that you notice here it's 0 to 12. I could have also written 0-12. That is a true range. A lot of times people will try to, if the range is say 2 to 12, some people might give the answer of 10. That's not the range. The range is not 10, meaning the distance between 2 and 12 is 10. That's not the case. The range is actually just giving me the lowest value and the highest value. And if you give me those 2 values, then you've given me the range, and that's all that matters. And that's it. That's all for range. The next measure of dispersion we're going to discuss is the mean deviation. And this one is a little bit more math. We're starting to actually get into our true stats equations now. Again, to reiterate, we will be giving you all the the statistical equations. They'll be all available for you in a number of formats for you so that you can access and reference that in the future. So just as the range only measures the extreme ends and ignores all the other values in the data, the mean deviation actually is sensitive to all the values in the data set. So in that respect, it's much better than the range. It's the mean deviation is just looking at the number of, so it looks at basically how much the values you're seeing deviate from the mean, which is why it's called the mean deviation. How much they are different from the mean. So one you want to measure is how different each value in the data set deviates from the mean. Number 2, it sums up all of these differences across all observed values in order to get the total amount of deviation. And then number 3, you divide this sum of deviations by the total number of scores in the data set to get an average deviation. So the mean deviation is essentially the average distance that a score deviates from the mean. I'll give you a detailed example now. So this is a table we talked about with the mean. This is exactly the same table we had previously. If you remember before, the mean is described as x bar if the mean of x is x bar. So the bar over the x means the mean of that x. Okay? So we know that the mean of x is 8, or x bar is 8, because we calculated this previously. And the mean is calculated as the sum of x divided by n. So the sum of this column, 48, divided by n, which is the sample size, which is 6. So 48 divided by 6 equals 8 cups per person. Okay? So x bar is 8. And if you remember correctly, we added this column previously, and this is just reintroducing it now. We added a column previously to check your data called x bar. So I just went down the column here and I entered x bar all the way down. And then I have a third column, which is called x minus x bar. And that's simply this column here minus this column. So 12 minus 8 is 4. 10 minus 8 is 2. 10 minus 8 is 2. 6 minus 8 is negative 2. And all the way down, and 5 minus 8 is negative 3. So to check your math, previously for the mean, what we did was you could sum up all of this data here, these data here, 4 plus 2 plus 2 plus negative 2 plus negative 3 plus negative 3, and if you did your mean correctly, that should add up to 0. So nothing has changed up to this point. For the mean deviation, your data are set up already. You've already got the mean. You've got the mean here. You've got the scores from all your people that you interviewed, and you've got how much, essentially what this is x minus x bar, is really how much is deviating from the mean. Here's your score, here's the mean, and how much is this score deviating from the mean? Well, it's 12 more than the mean. Here it's actually deviating by 2. It's 2 more than the mean. Here it's 2 more than the mean. Here it's actually 2 less than the mean. Here it's 3 less than the mean and 3 less than the mean. So this is how much it's deviating from the mean. So again, you remember that the sum of x minus x bar equals 0. That is to say, if you add up these x minus x bar values here, it will equal 0. So as a result, simply summing up x minus x bar actually won't give us the total deviation from the mean. So in other words, you can't just add up all of these and say, oh, the total number of deviation from the mean is, because you're always going to get 0. So that's not going to be very helpful. So what you actually have to do is ignore the sign, positive or negative direction from the mean, to actually get the total deviation. So this is very similar to like an odometer on your car. When you go in drive or in reverse, it's still adding mileage. It doesn't matter. It doesn't care which direction you're driving. So if you ignore the sign, it's actually referred to as the absolute value. And in this case, here, it's positive 4, positive 2, positive 2, and then we're going to ignore the sign, and we're going to make this a 2, 3, and 3. So 4 plus 2 plus 2 plus 2 plus 3 plus 3. Again, the absolute value for the mean deviation equation. So the absolute values are shown in the statistic symbols using simply bars. So x minus x bar, and then these two vertical bars here are that is establishing that you actually are looking for absolute values. So when you see these two bars here, that means ignore the sign that this gives you. If this gives you a negative number, ignore it. I only want the positive number. So the mean deviation equation is just abbreviated by MD, mean deviation, equals the sum of x minus x bar, but the absolute values of that, divided by n. Okay? Again, if we didn't do the absolute values of this x minus x bar, we would just get the sum of x minus x bar, which right here, as I see it here, is 0. 0 divided by n is not what we're looking for. The sum of x minus x bar, but the absolute values divided by n is the mean deviation. So here we have the mean deviation. 4 plus 2 plus 2 plus 2 plus 3 plus 3. That's simply 4 plus 2 plus 2 plus 2 plus 3 plus 3. I ignored these signs here. and I have the absolute values, and that gives me 16. So these numbers all added up, ignoring the signs, gives me 16. And I'm dividing it by the sample size, which is 6. 16 divided by 6 gives me 2.67. Again, the stats equation for mean deviation is the sum of absolute value of x minus x bar, and then that value divided by n. So the mean deviation is 2.67.